Welcome to the XtextCasts. In the episode 15, I talked about output configurations, how to define a custom output configuration and how to use it within an AI generator. In this episode, I will talk about how to use output configurations with the Xbase and the ModelInferrer. In the episode 15, we used standard Hello World Xtext grammar unmodified. In the generator, we generated two files, greetings.java with an interface and greetingsimpl.java with an implementation. And for the generation of the greetingsimpl.java, we used our custom generate once output configuration. And this means if greetingsimpl.java file exists, it doesn't get overwritten. In the output configuration provider, we copied the definition of the default output configuration and appended our new read-only or generate once output configuration. We choose a source folder as output directory, and we choose not to overwrite existing resources. Finally, we bind our output configuration provider in the MyDSL runtime module. First, let's go to the Xtext grammar and extend it from the Xbase. And then run our generator. The generator runs successfully, and now let's open ModelInferrer. I just paste the code that does the same as the generator from the previous episode. I generate interface, my greetings, and set interface to true here, and I generate a method for each greeting, and then I generate an implementation class that implements my new interface and has a method for each greeting with the default body. Now let's run our second Eclipse instance and see how it works. This is a greetings MyDSL file I prepared with the 3 greetings, and when I save it, we get 2 files generated, the interface with 3 method definitions and the implementation of this interface with the 3 methods. Back to the main Eclipse instance, let's use our generate once output configuration. In the previous episode, we provided the name of the output configuration as a second parameter to the generate file method. With an Xbase and ModelInferrer approach, we cannot do it so easily. The ModelInferrer maps the domain model elements to the Java model elements. So we will have to mark the Java class model element somehow to save our alternative output configuration name. And we can do it using adapters. Each model element has a list of adapters. We define our custom output configuration adapter that saves the name of the output configuration. Later on, we will find this adapter and use our alternative output configuration. Let's add output configuration adapter. And I put it into the output configuration package, and it should read output configuration adapter and implement the adapt interface from the AMF library. The default implementation for these 4 methods is good enough, and I will just paste the couple of lines to take the name of the output configuration in the constructor and save it into the field, and also provide it through the getter. Let's add a generator that can handle our adapter and output configurations. And it should extend JVM model generator from the Xbase compiler package and override doGenerate method. If we will take a look of the doGenerate method, we will see that it iterates over the root elements of the input resource and call internal doGenerate method with each root element and the file system access. So this looks like a good place to interfere. The little gotcha is that we will have to use internal knowledge about JVM model generator though. Back to our generator, I will paste the code and then explain it. Here I do practically the same. I iterate over the root elements of the resource Then I iterate over an adapter of each root element and look for output configuration adapter. If I found one, I save the name of the output configuration and break this inner loop. If no output configuration name found, I use the standard way to call internal do generate. But if I find one output configuration name, then I have to alter this call so that output configuration name get used. In order to do this, I will wrap file system access and provide my custom output configuration name in the constructor. But before doing so, let's register our new generator. So I go to my runtime module and override bind iGenerator and provide the name of my new generator class. Now let's turn our attention to wrapping iFile system access. It can be complicated since we also have two extension interfaces, and an instance implementing iFile system access can also implement one of those extension interfaces or both of them. Since this kind of code is likely where we check if an instance implements some of the extension interfaces and then call a method on this extension interface, our wrapper class has to implement the same interfaces as the class that we want to wrap. So actually we need 4 wrapper classes. But in our particular case, the single class that implements iFile system access also implements both extension interfaces. So we get away with a single wrapper class. Let's create the wrapper class. And I call it single output configuration file system access. And it implements these 3 interfaces. And the implementation is very simple. It's done with a single snap. The implementation is fairly straightforward. In the constructor, I accept and save an instance of iFile system access and output configuration name. All methods I delegate to the instance of the file system access, substituting the output configuration with the stored output configuration name. Finally, we can go to our generator and use our new wrapper class. Now let's run our second Eclipse instance. In the second Eclipse instance, we generated last time the interface and the implementation files both into a source gen directory. Now, if we are clean and rebuild the project, we see that the implementation file get generated into the source directory, whether the interface stays in the source gen directory. Now we can safely modify this implementation. Now, if we go to our model file and add another greeting, then we get expected compile error. And this is because the new greeting was generated as a method into the interface, but not into the implementation, since implementation was already present. So we have to solve this compile problem using quick fix. Thank you for watching XtextCasts. Go to the XtextCasts.org to get show notes, discussions and more episodes.